Machine learning models are increasingly used in medicine. How can we ensure they are reliable enough to support medical decision-making?
My name is Anne-Laure Boulesteix. I am a PI at the Munich Center for Machine Learning and Professor of Biometrics at the Institute of Medical Information Processing, Biometry and Epidemiology of the Faculty of Medicine at LMU Munich.
My name is Milena Wünsch. I am a PhD student at the MCML and also at the Institute for Medical Information Processing, Biometry and Epidemiology at LMU. So imagine you want to compare two methods A and B on a set of data sets. And then it is quite common in this comparison that you encounter, let's say, for example, method A fails to produce a required output on one or more of those data sets. And this is actually a quite neglected aspect in comparison studies. Researchers often don't really know that this actually has an impact on the results of the comparison study. So depending on how you handle it, it is quite common to just remove those data sets where method A fails on. However, doing that, you're quite likely to induce a bias in your results. And so that one method is actually artificially favored solely by the way you handle this method failure.
This is a very important source of bias that you addressed in one of your PhD projects, but there may be further sources of bias. For example, if I am more familiar with one of the methods, or if I allocate more computing time to one of the methods. These are all problems that may ultimately lead to a biased evaluation of methods.
Yes, and here it doesn't really matter if you're consciously or willingly manipulating your results. There's also a lot of aspects people aren't even aware of that may artificially influence the results of their study.
In methodological research, we have every day plenty of papers claiming that a new method was invented that works better than other methods. And at the end, for people applying these methods, this may be really confusing.
Or they might also pick a method that has been chosen as the best performing, which actually in reality isn't. So they apply a falsely best performing method to their data, meaning that the research findings that they produce might not be reliable or might not even be valid.
There were positive developments in the last few years regarding methodology of methodological research. And that's why I'm quite optimistic that in 5 or 10 years we will have more reliable machine learning.
What really motivates me about this topic is that it is so present in so many fields, in methodological research, but also in applied research, and that I can investigate it just across many disciplines of statistics, but also in medicine.